going to walk you through a demonstration that involves Kafka, large language models, and input-output processing. This is not a chatbot, so think of this as a Gen AI agentic system, no chatbot, meaning it's more of a batch system. Any enterprise is going to receive a lot of messages. So if you're a big organization, you have people emailing you all the time with things like support cases. I want to get my invoices, my payment history. You have a duplicate payment on my credit card. I have a bad password. I can't log into your website, right? You're going to get all these emails, job applications, things of that nature. And it could be WhatsApp messages, text messages. It doesn't just have to be emails. So this is a universal inbox solution. And I'm using open models, and you're going to see those all in action. And the goal of it is to receive a bunch of messages. In this case, I'm going to just look at a file folder. I'm going to intake them. That just simply loads them into the system. And then I'm going to apply message structure. So the first effort that you want to use your large language model for is, can I identify notable things within the message? In other words, does it kind of sort of look like a customer to us in our organization? So it uses a pedantic model and applies structure. Once it has identified structure, it then applies guardrails, if you've heard that term before. This uses the Granite Guardian model, and we'll show you an example of that. It looks for hate speech and profanity, things of that nature. If it gets cleared, then it just runs another component, right, that just talks to a database, right? And if it can find that customer in our database, then of course it makes it ready. And now it has all the customer details. It can now do the appropriate routing. And it's going to route it to the support team agent, the finance agent, the website agent, as an example, depending on what it finds as content. So content-based routing, but in this case, using natural language processing. And then, of course, it can send it off to the support team, the finance team, the website team. And there'll be a special thing we'll show you towards the end where it identifies the anomalies. So the review topic here are for exceptions, anomalies, and things of that nature. And we're going to go back and review that towards the end of our demo. And that's where we use Deepseek. So let's actually walk through this, and then we're going to show you the code too, okay? So let's actually fire off a message to get started. Let me check on my dashboard here. It looks like it's all connected. So the different topics you saw on that diagram are represented here with a little chart. And I'm going to just push a message into the system by using copy, okay? So it just has to go to a certain location. There's a bunch of sample messages I have out here, and I'm going to say, let's copy the tech support to the intake folder, right? So if it goes to the intake folder, it immediately gets sucked in, and you can see it says here, I need help with cloud sync. So this is a tech support-like question coming in, and it has a name, it has an email address. And so the first order of business, if we go back over here, is can I identify stuff in it? And you can see it's pulling things out, customer name and product name, cloud sync. And therefore, it moves to the structure, right? It passes the structure. Then it passes the guardrails. Then it's ready for routing, and it's ready for the support team, which applies RAG, retrieval augmented generation. And once that's all done, it can go to the outflow topic, which basically means it's ready to go back to the customer. So again, an agentic system, it applies its own rules, it has its own dynamic router, and it can dynamically respond to the customer on its own if that's what we want, or human in the loop, I want to basically approve it. Let's actually walk through the code though, and while that's firing away, let's actually get another one going just to have that in the system. Yeah, okay. So we're going to keep firing off messages as we go as we look at the code here. And so there's a big README file associated with this project. You can see all the different commands to run it across all those different windows. The first thing is the file intake. So it's going to basically try to apply this what's called an outer wrapper pedantic model, some metadata from the file that it ingests. So there's no large language model here. This is just standard code for ingesting the file off the disk. You know, it marks the file as done, right, when it's done. And then, of course, just keeps looking for files, right? That's all it's doing. It's just spinning and looking for files and then applying it with a pedantic model, serializing that, putting it in the Kafka topic. And then the next thing is with a large language model, it's extracting structure. So this is a superpower we've never had before. I can use a large language model now to basically determine that I want to identify interesting stuff in that message, right? Is there a reason for your email? Are you a customer? Or at least what, a human name, email address, a product identification, and kind of maybe sentiment analysis. And depending on the model you choose, you're going to get better sentiment analysis or a better escalation flag, things of that nature. And you're going to see that being pushed to the system. Let's go check on our dashboard again. See, there's the Tech Gear laptop now flying through the system. Let's go ahead and shoot some more messages in as we go review our code. Let's also do let's try a job applicant. And I'm just going to be kind of random here. And I'm on a bulk order. We're just going to get a couple more things going. And maybe I also want a order history request, right? So customer is saying I want my order history information. Let's get that going. And again, you're going to just see that flying into the system here. But let's continue our call through. So the message structure is important. Then there's the message guardian. It's looking for things like violence, social bias, hate speech, profanity, right? So it's looking for that sort of thing because I might not want my employees as a big enterprise to receive socially biased or hate speech in their inbox. Okay. I want to protect my finance people, my sales people, my support people from that sort of hate speech. And I'm going to deal with it accordingly. As a matter of fact, depending on how ugly it is, maybe I will send appropriate security people after these people who've been emailing me hate speech. But I have a filter now for that. Again, a natural language processor based on the Granite Guardian model. So that's that step there. And let's go back and look at our diagram. So you can see that's the message guardian. So the next phase is the customer lookup. If we go look at the customer lookup here that one is, it's just going to do a database query. Can it find this customer in our customer database? That's all it is. And if it does, it has additional details it adds to the message. So the message gets enriched as it goes through this pipeline here. So, that's a standard enterprise integration pattern. We're going to enrich the message. So the customer lookup actually doesn't involve a large language model. The message router, though, does. So based on the content of that message, can we figure out it really belongs to the support team, finance team, website team, or maybe it's unknown? And again, if there are any failures along the way, meaning, and the failure could be for any reason, it goes to this review topic. Okay, so you'll start seeing the review topic being populated. Let's actually go look at our dashboard again one more time. Okay, and you can see that there are some review topics, meaning we don't really have a job application processor. That maybe we should add one to our corporation. We don't actually have a non-customer prospect processor, right? So you can see there are some things building up here. Let's add some more messages to the system though, because the system's actually performing really well right now. So the other thing I wanted to do with the system was deal with not only the non-deterministic information, but non-deterministic latency. So each of these models takes its own, bucket of time to process. We're just going to keep pumping in some stuff there. And you can see it should be flowing through the system. All right, fantastic. And let's go back over here and back to our code review. Okay, let's keep looking at this. So if it in fact is support can actually query the database for vectors. And that's because this is retrieval augmented generation. It takes the query from the user, looks in the vector database, in this case PG vector, tries to find a match, then takes those documents and sends it to the large language model as additional context. Let's see if I can find the large language model additional context part here. So there's the question. See, it says use the additional truncated context, and then based on that context, the large language model can respond. This is where you assume the large language model does not have all the data. As a matter of fact, it does not have our private data. It does not have our private support documents that are not on the internet. So therefore, it should respond with retrieval augmented generation in that case. There's also the finance responder, which basically has a bunch of functions or tools, as they're called in large language models. And these tools, which are identified here in JSON, are going to basically be API calls. So there's actually an API back over here, right, that gets invoked based on this. Now, one thing I'm doing everything here in Python, but each of these processors that are large language model infused could actually be a Java, Python, JavaScript, right? The language doesn't matter. I did everything in Python just for the sake of keeping it easier for people who are looking at the demo. But every one of these could be fully independent. This is a microservices architecture. Each of these things is independently deployable, redeployable, and could be written in whatever language they want. We're using Kafka to deal with non-deterministic data in terms of responses and non-deterministic latency. Okay, and so you can see that that's pumping through the system. Let's go back now and look at our dashboard and see what we got here. Okay, you can see there's a bunch of stuff here. And we have some nasty messages now, so you can see those in the review topic. There's an example of social bias as an example. This is not a real group as far as I know. So maybe there's some social bias against them, and therefore we don't want our customer service rep seeing that. There's also some data here that's pretty important. Actually, let's try one more like that one, because this is important data. So let's not do that. Let's try this one over here. Dun, 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 dun. Yeah, I didn't push that one in yet. Okay, so we have some other interesting data here that's showing up in our system. We have people who are emailing us. They have urgent purchase requests. The part that's interesting about this, our existing system, which let's say didn't handle WhatsApp yet or didn't handle text messages yet, also didn't handle prospects yet, meaning people who are not yet customers. And this is an example where Susan Smitherman here is not yet a customer. She's a prospect. And therefore, our system didn't handle that. But we're still capturing all these issues in this review topic down here. You can see there's a bunch of them here. So we can now bring another processor online. We, as an organization, could notice, well, we're building up a lot of interesting things in our review queue. Can we do something about that? And so I have one last bit to the demo here, and let's go look at it. And I call it the Opportunity Finder. And this one uses Deepseek, which is a reasoning model. And what's cool about a reasoning model is you can ask the model, what prompt ought I give you? It'll tell you what prompt you ought to use, and then you can programmatically use that prompt. So I actually had a conversation with Deepseek, just as a chatbot, and said, look, I need to handle sales, I need you to detect interesting sales or purchasing initiatives, or, look for the word buy, purchase, order, price, look for people who want to buy stuff. Ignore the profanity, ignore job applicants, ignore all the other stuff, because that's what I wanted to do. I just wanted to find the sales opportunities. If you find a sales opportunity, I also wanted to use the reasoning model to do something else that was kind of clever. Automatically create the code that then sends it to the sales team. Okay? So in other words, the code is actually generated by the reasoning model in addition to detecting in the message that it ought to generate the code. Okay, hopefully that makes some sense. So this one's a little bit fun, and this is why you would use our reasoning models, because one, they're great code generators, but you can also ask it how it ought to reason. It'll give you a really cool prompt that you then use in your code. So this crazy prompt I have here was mostly me just chatting with it and it saying, oh, here's a good prompt for you. And so I just, put it in here. I tweaked it a little bit for my needs. And you can see it's basically going to, if it finds a sales-worthy question, it's going to then generate the code to send it to the sales Kafka topic. Okay? So let's give that a try. Let's go ahead and give that a try. So over here, right, you can see there are some purchasing questions in here in addition to other things that I've collected, like job applicants, things like that. But I want to see if I can review that, and let's see if this works. Okay. This is all live. I'm, kind of doing this on the fly here. So we've got things in the review queue. This is an example review queue up here, and let's run the Opportunity Finder, and let's see what it finds. So it's reviewing this Dude McKesson, and let's see if it can find something for Dude McKesson. Dude McKesson was, I don't know where that one was. Dude was a job applicant, so that shouldn't go to the sales team. So let's see what else it finds. Okay, it's got one for James here. It found James. Let's see if it can figure out what to do with James. So it's thinking about it. And so it hasn't finished with James yet. But again, by the way, a reasoning model is even slower still. Okay, if you've tried one of the reasoning models out there before, it may take several seconds to respond. And there we go. It decided the James message was in fact sales worthy. And you can read the text here. You can see, James, who may not yet be a customer, is trying to buy some stuff from us. What else is it doing? It's going to review, this is obviously not worthy of our sales team. So it's going to ignore that one, we hope, as an example. So some nasty message coming in from somebody. Now, we might want to decide we have another processor that goes and figures out what to do with that, but it looks like an anonymous message that basically is cursing at us, so we might want to ignore that one. And then, the Susan one here, let's see if that one is sales-worthy, and it is. All right, so that one decided that it is sales-worthy and set that up. So this is why I wanted to build a system like this. One, I think it's an enterprise-style system. One, it can handle anomalies. It can handle non-determinism. It can handle anything that comes into the system, and it can be dynamically reconfigured based on the inputs and outputs of all these Kafka topics. So you can rewire the whole system very easily. And one thing you could do in the future with a reasoning model is let it determine the wiring, okay? Kind of that's what the Opportunity Finder does. It's determining the wiring and how the routing is occurring by basically saying, look, we're going to put the logic in, and based on what it finds, send it to the right location. So that's an example where you might want your agentic system to do its own planning. So my current system, it has a kind of a fixed plan, a fixed workflow, if you will, that I can dynamically add things to and change things in an event-driven architecture, microservice architecture way, or I could even expand on it further. Okay, so hey, this is awesome. I just did this all live in this recording, and it all ran just as I expected it to. But of course, this is just a bunch of code that is out there on GitHub. The link will be in the video description, and please give it a try and give me your feedback on it. You can always find me on the internet in various ways, but give that a try, and then hopefully you can have your own agentic system using all these really cool large language models as you see here. Deepseek, Mistral, Qwen. I like the Qwen ones a lot, by the way. Granite Guardian for my guardrails, right? The Granite Instruct for tool calling. It's actually one of the better tool callers. So depending on which model you need, you're going to use a different a model for a different purpose because they all have different capabilities. So I wanted to show a bunch of them here in this system. All right, well, thank you for your time.